Hi, here I'm going to show you how to rationalize the denominator when your denominator has more than one term. You notice here we have 4 over 1 plus the square root of 2. So we have a binomial in the denominator, which means we need to be careful about how we rationalize it. The idea behind rationalizing the denominator is to rewrite it in such a way so that we don't have this square root of 2, meaning no radicals inside the denominator, so no roots whatsoever. Our first option, well, we could do something similar to what we do if we only had a monomial, meaning let's for a moment pretend this 1 wasn't here and we had just the square root of 2. To rationalize that, we would end up multiplying top and bottom by the square root in 2 and get this. So option 1 would give us multiplying top and bottom by just the square root of 2. We get 4 root 2 over the square root of 2 plus 2. So you notice doing this did not help me out very much, because though I got rid of this square root, since that becomes just 2, I introduced another one. So this is not going to help me out. So option 1, though it's similar to what we do when there's only one term down there, it's not going to help me here. Option 2, this would be somewhat like the idea of just squaring the bottom. So instead of multiplying top and bottom by the square root of 2, let's multiply top and bottom by 1 plus root 2. If we do this and simplify, what we'll end up with is 4 plus 4 root 2 all over 3 plus 2 root 2. So you notice even doing this, even basically squaring the bottom, so multiplying top and bottom by 1 plus the square root of 2, we end up still having a square root in the bottom. So neither of these options are going to work for us. So unfortunately, neither of these will work. What we want to do is instead multiply by a different amount. We want to multiply top and bottom by the conjugate. The conjugate for a pair like this is going to be the same two amounts, 1 and the square root of 2, but instead of adding like we do here, we're going to do the reverse operation, the opposite. We're going to subtract. So these two pairs, 1 plus the square root of 2 and 1 minus the square root of 2, are called conjugates. We multiply top and bottom by that, and we'll end up rationalizing the denominator, meaning in the end, once we simplify, no radicals, no square roots in the bottom whatsoever. So let's see how that works. We saw these options did not work, so we'll start over and try this again. The original amount that we have is again 4 over 1 plus the square root of 2. We're going to take this and multiply top and bottom by the conjugate 1 minus the square root of 2. Whatever we do to the bottom, we got to do to the top so that we keep the fraction equivalent. So in the top here, we're going to go ahead and distribute, meaning multiply this 4 into both terms. So we end up with 4 minus 4 root 2. It's perfectly fine to have that radical in the top. What we want to see is when we FOIL the bottom, if we get rid of the radicals in the bottom. So down here, we're going to go ahead and FOIL, and we treat square root 2 fairly similar to how we would treat a variable and multiplying this through. In the end, if we have any like terms, things that we can combine that have the same radical in them, we will. So first up, we get 1 times 1, so 1 squared, which is 1. We're going to have minus 1 times root 2, so root 2, then plus the square root of 2, then minus the square root of 2 squared, which simplifies to 2. So all of that's in my denominator. And what I said with the idea of this being similar to how variables work, you notice we have this minus square root of 2 plus square root of 2. Those are like terms, which means we can combine them. And in this example, since they're the exact same amount but opposites, you notice they're going to cancel out and give us 0. So when we simplify this, we're going to end up with the amount 4 minus 4 root 2, the top stays the same, over 1 minus 2. Well, 1 minus 2 is just negative 1, so we're going to end up with, and again, running out of room here, so let me move this up a little bit. We have here 4 minus 4 root 2 over negative 1. Since we are just dividing by negative 1, I'm going to divide just to simplify this, get it to look a little bit nicer, and realize that this is the same as minus 4 plus 4 root 2. It's just dividing each term by negative 1. And that is the rationalized form. In this instance, since our denominator turned out to be 1, we can write it without the denominator, but the important part is, you notice no square roots in the bottom, and that's what we absolutely want to be sure of.